Hey guys, today we're starting Unit 8, Section 3. We're going to be talking about the pH scale, which is probably going to be a review for a lot of you, especially if you took Earth Science, and then starting to get into some of the properties of acids and bases. All right, pH scale. pH scale determines the level of acidity or basicity of something, so how acidic or basic it is. Ranges from 0 to 14. If it's down at anything less than 7, that's considered an acidic solution. If it's greater than 7, it's basic, and only at 7.0 is it considered neutral. 7.01, basic. 6.99, acidic. Okay, so only at 7.0 is it neutral. So by definition, pH is actually measuring the hydronium ion concentration. And hydronium is the combination of H2O plus an H plus ion, which, which gives us H3O with a positive charge, because it has an extra positive, which is that extra hydrogen. So that's what hydronium is. And it comes from little hydrogen ions, or the H plus ions, attaching onto water. Okay, and that's going to come in. That's going to become important in a few minutes. Okay, so ions released, hydrogen ions are released by acids when they dissolve, and we'll get back to that. Make sure you record this. Okay, so the more hydrogen ions there are, the more hydronium you're going to make, because the more H pluses you have, it'll attach to the H2Os, you'll make more H3Os, okay? That means it's more acidic. If I have less of those, then I'm going to be more basic. And the pH scale is known as a logarithmic scale. So if I say, oh, it has a pH of 1.0 versus a pH of 2.0, that means that 2.0 is 10 times stronger, okay? So it isn't necessarily just moving up by a power of 1. Here's the pH scale of some common substances around the home. I recommend you pause it, just kind of look over it, get a basic idea. Notice, though, that the only thing registered at 7.0 is pure distilled water, okay? Everything else is more than likely going to fall into a different pH level. pH indicators are used to tell us what the pH of something is, but it is a little bit of a vague term, okay? And you'll notice over here I have a list of a bunch of indicators. The only two that we are going to use will be universal indicator and phenolphthalein. And so universal indicator shows us all the way from 0 through 14, and universal indicator, it also shows us a gradient, so you can see it changing colors as you go across. However, you have to estimate some of those intermediate colors, which can be a little bit, sketchy. Phenolphthalein starts at 8.3, so as soon as it shifts just to the basic side, and will go from there up to kind of a fluorescent fuchsia pink. Otherwise, it's colorless. All right, so when we have acids and bases are not really considered an acid or a base until it is put into solution, because the idea of being acidic or being basic is based on an action, not on a basic fact. So acids are considered acidic because when you dissolve them in water, they release hydrogen ions. Okay? Bases are considered basic because when you release them in water, a lot of them are going to release OH, which will gobble up H's very quick and turn it into H2O. Okay? So acids increase the H pluses, which therefore increases the possibility of H3O. Bases decrease H plus, which then decreases H3O. Okay? And we'll come back to that a little bit. We'll practice it next time. But basic idea here that I really want you to gather is acids release hydrogen in water. Bases absorb hydrogen in water. All right, these are some basic properties of acids and bases, things they both have in common. Since acids and bases are both ionic compounds, they release ions in solution, and therefore those ions enable them to conduct electricity. Acids and bases can react with one another, and when they do, if they're in the right molar quantities, they create neutral solutions, so about 7.0. They're able to affect pH because they either increase or decrease H3O concentration, and H3O concentration is what pH is a measure of. So by increasing or decreasing that, they're going to change the pH and cause pH indicators to change color. And a lot of people think acids are really, really dangerous, but they don't know a lot about bases. Let me tell you, both are extremely dangerous to human health. They can be just as dangerous as one another. All right, last thing, and I would put it in your notes literally like this, not necessarily with bases at the bottom, but at least a T-chart so that you understand the properties that are different. Acids are going to create solutions with a pH that's less than 7.0 because they're going to release a lot of hydrogens. Bases absorb a lot of hydrogens, so they're going to lead to a pH greater than 7.0. Acids can react with metals. They produce H2. Carbonates produce CO2. You don't necessarily need to focus on anything other than to realize that acids a lot of times release gases. So when they react with things, they cause bubbling, and a lot of times that means that something in there is acidic. If you were to taste them, they taste sour, and as mentioned, they release these hydrogen ions and increase H3O. Bases taste bitter. They generally feel slippery. It's kind of strange, but if you have them between your fingers, they feel extremely slippery. They will either release OH or cause water to release OH. Either way, they absorb H+. Okay? And by absorbing H+, they reduce H3O. All right, so I want you to review this slide and make sure you guys come to class with questions. Have a good one.